Hello, I am Songyeon An presenting the project Campus Placement Classifier. Before I go through with the project, I would like to explain what campus placement is. Campus placement is the strategy for hiring young talented students for entry-level positions among companies. There are several cases such that campus recruitments lead students to grab higher chances, such as getting hired from conglomerates. These days, placement is one of the most considerable issues among students, which are us. There is a phenomenon that most students confine their studies only for employment. As such, most students think that placement takes the largest part of their life, and many students get a lot of stress from it. So the campus placement classifier can help students to prepare for employment more wisely and release their stress, as the predictor predicts whether students can be placed or not based on their educational backgrounds. It can also give an insight at which factors are needed or should be proved to be placed in the company. The main goals of this project is to classify and predict whether the certain students will be placed or not according to their educational backgrounds. I used the random forest classifier algorithm as the main machine learning technique in order to design the model. So the input will be the information of educational background from students, and output will be the results of the placement, whether students will be placed or not after going through the AI model. The dataset I was able to acquire on Kaggle contained 215 distinct personal placement results. It is conducted around the placement season of a business school in India, whether it has various factors on candidates getting hired. It consists of 15 columns, including the serial number. It consists of information regarding gender scores of secondary, higher secondary, and undergraduate specialization of each education level, work experience, employability test scores, and finally, the status, which represent whether a certain candidate is placed or not. Mostly, scores and status of the placements are used as factors for designing the classifier model. Before implementing the random forest algorithm, I went through with some statistical analysis with the dataset. First, analysis about the counting of each attribute presented in the dataset. I could observe that there are more male candidates compared to female candidates. Most of candidates do not have work experiences. Most of the candidates specialize the field of commerce, and most of the candidates got hired by companies. Second, analysis is about the distribution of each score factor. All the distributions follow the normal distribution, as all the graphs are represented in the bell shape. Most of the educational performances from the candidates are between 60 to 80%. The last analysis gave overall insight regarding the relationship between score factors and the result of placement. It is about the distribution of each score factor with relation to placement results. I could observe that among several score factors, candidates who got higher scores in higher secondary and undergraduate education are placed more. Basically, candidates who got higher scores have more chances to place, and this implies that scores got from schools are highly influenceable toward the results of placement. And now I will talk about the proposed method for designing the model. Before applying the random forest classifier algorithm, I pre-processed the dataset first in order to fit into the random forest classifier function and increase the accuracy of the model. Data pre-processing methods are divided into 4 steps. First, I remove the outliers. The outliers are unusual values in the dataset. It can possibly hinder the statistical analysis of the data and decrease the accuracy of the AI model. Therefore, I decided to remove them in order to improve the accuracy of both statistical analysis of data and the campus recruitment classifier model. I could observe that there are outliers in higher secondary education and undergraduate score factors. I removed the outliers from these two factors, and a new quantile representation of data is shown below in the figure. Second, I did the label encoding, which is the process of converting attributes that consist of only two types of classes into either label 0 or 1. On the other side, some factors are more than two types of classes, which are specialization in higher secondary education and specialized field of degree education. I separated them individually and expanded them into new data by using the dummy function. Third, since I'm designing the model that predicts whether students are placed or not according to their educational background, I assign the status of placement as a target variable, while the educational background is assigned as the input variable for training the classifier model. And lastly, I split it training and testing sets since there is no clear division of training and testing set in the given data set. I randomly divided the data set into two sets, which are 70% of training and 30% of testing. Now data is well pre-processed and I applied the random forest classifier algorithm into the data set. The accuracy of the classifier model is around 86%, which is, I think, high enough to successfully predict whether certain students are placed or not based on their background. This step is an additional step for improving the accuracy of the model. After designing the campus placement classifier, I observed the important features and specialized fields from higher secondary and undergraduate education are not that much important for training. So I removed them in order to make more decision trees by the random forest classifier algorithm. I believed it could increase the accuracy, and the accuracy really got increased. The accuracy of the previous model was around 86%, and now the accuracy of the new predictor model is around 89%, which is a bit higher. I tested the campus placement predictor with arbitrary information. I tested two cases which are with a high score of secondary education percentage and with a low score of secondary education percentage, as the secondary education score was the most important feature. The test case with a higher secondary education score is resulted as place, while the case with a lower secondary education score is resulted as not place. It seems that the factor of secondary school score really influences highly on the result. In conclusion, I was able to classify the results of campus recruitment, whether the students is placed or not, by constructing a prediction model with the random forest classifier algorithm. Even though the results are not perfectly accurate, they still could be utilized to predict the placement result. This campus recruitment classification model can be treated as the consultant, since students can easily notify their weakness and which factors need to be proved for the placement. And thank you for listening.